Okay, for the last concept where it is distribution approximation, bermaksud kita ada pertukaran distribution di sini. Okay, so pertukaran distribution daripada binomial ke normal distribution. So this is what we said, we use normal distribution to approximate binomial distribution, untuk menghampiri binomial distribution. So what's the situation or what's the condition? The first one, n is large. N is greater than 50. When you read the question, we are doing your binomial, suddenly your N is increased more than 50. So means that that situation or that distribution is no longer suitable to use binomial way to solve it. So we have to change to normal. Alright. So why is N is 50? You notice that your statistic table here, you can notice that in your binomial, the maximum sample that you can reach 50. Selepas more than 50, no more table already, right? So that is one way you can remember lah. You look at your table, more than 50 for binomial, you're not suitable. Okay, second condition, your mean NP more than 5, or you can find NQ more than 5, either one. If you notice that your mean more than 5, also in that situation, your binomial is not suitable. You have to change it to normal. So we will use normal distribution untuk menghampiri keadaan itu, untuk approximate that binomial distribution. And in your syllabus, probability P, because your binomial X, your parameter is NP, your P here is in between 0.1 and 0.9. So originally X in binomial is discrete random variable, but when you want to change it to normal distribution, where mean and variance here, your X here is changed to continuous random variable. So dia daripada satu bidang, satu field ke satu field, satu bidang ke satu field. So dia melangkau from discrete to continuous. So how to do daripada discrete to continuous? Our X here, when you're changing from discrete to continuous, so your X here, you have to do your continuity correction. So you have to make it continuously. From a discrete thing, you have to make it continuously. Alright, so what is your discrete previously? Kalau contoh discrete, 1, 1, 1, 1, betul? So you want to change it to continuity correction. You want to change it to continuous random variable. You might be going to plus or minus 0.5. Tambah ataupun tolak 0.5. So for each situation, tambah tolak dia lain. Bergantung kepada dia punya equal or not. Bergantung kepada situation when you have equal or not equal. Alright? Faham ke? So ini soalan kita. Okay, so we back to here. Firstly, we analyze our binomial distribution. When you notice that n greater than 50, mean more than 5, you notice that the distribution have to change to normal distribution. So how do you get mean here? How do you get mean here? How do you get mean from binomial? Yes, NP. How you get variance here? Yes, NPQ. So this is how you define your new distribution into normal. Alright? So when you look at the question that originally from binomial, we need to do continuity correction so that the X is in continuous random variable. So how to do this continuity correction, whether you plus or minus, like dia macam konsep letak boundary untuk discrete kamu. Okay, so let's say so before this discrete 1, 1, 1, 1 macam ni, betul? So when you have sample sangat banyak, Bila kamu ada sampel lebih daripada 50, dia bila jadi sangat banyak, dia akan jadi, bila banyak, so dia akan jadi normal distribution. So itu yang jadinya. So you have to do your CC. Let's say more than A. Let's say I put a value Px more than 3. So when this is 3, 4, 5, 6 in discrete, you have 3, you have 4, you have 5, you have 6, right? So how to do the boundary here, and so on, and so on. How do you do the boundary here? Your boundary will be located before 3. Correct? Betul? The boundary before 3. So when your boundary located before 3, so when you're doing CC, continuity correction, it will be x more than before 3. So the value will be 2.5. So now it becomes a continuous random variable. So now it already fulfills the normal distribution. So that's why when you have more than A, more than equal A, your boundary will be before A. So your A kena tolak lah 0.5. Boleh? Ingat balik tak ini satu-satu ni apa benda? Ni satu-satu garis ni apa benda? Satu-satu ni apa benda? This is our discrete graph from topic before this. Betul? Satu-satu, betul? Betul? So bila kita nak boundary kan dia, kita nak buat continuous dia, so kita kena tengok boundary dia kat mana. Janganlah ambil sampai 2. Kita nak decimalkan dia saja. So daripada discrete kita nak decimalkan dia jadi continuous. So kita plus ataupun minus 0.5. Faham? So when you're having A, okay, so we explain this concept one by one. So if you're having A, more than A means more than A, you will have your discrete one by one more than A. A, then A plus 1, A plus 2, A plus 3. So your boundary will be start before A. So before A, you minus 0.5 lah. Faham? So if you have this one, second, more than A, is it A involved? So it will start with A plus 1, A plus 2, A plus 3, A plus 4, so continue, betul? Contohnya kalau saya letak nombor, kalau ni 3, kalau ini 3, so sebelum 3, 2.5. Kalau ini lebih daripada 3, adakah 3 termasuk? Tak. So kita punya discrete start from 4, 5, 6. So where's your boundary to be put? After A, correct? So after A, your decimal will be plus 0.5, 3.5. Boleh. So continue. Kalau less than A, A include or not? Include. Less than A means here you have the random variable be less than A, semua terlibat, betul? So where's your boundary? Boundary dia akan berlaku selepas A. So tambahlah 0.5. Tak bolehlah sebelum A. Kalau sebelum A, you akan tertinggal satu nilai kat situ. You akan exclude nilai A dah, betul? Okay, so in this one, less than A not included. Not included A, so A sini ada discrete random variable tak? Tak ada, so dia akan less than, maksudnya sebelum lah, betul? So your boundary can be done before A. So before A we minus, after A kita tambah 0.5. How about in between? How about in between A and B? You can see A and B included or not? Included or not? Included means A ada, tengah-tengah ni semua ada sampai B. B pun included. So your boundary before A, after B. So before A minus 0.5, after B plus 0.5. Okay. Okay, so teruskan. Kalau not included, A, B, if you not included, A sini ada discrete ke? Tak ada. So after A. Sampai B tak? Tak. So you punya boundary, we can do after A, before B. So when you after A, we plus 0.5. Before B, we minus 0.5. So when you have exactly value here, satu saja. X equals to A, satu saja. Boundary kita sebelum A dan selepas A. So A will be minus 0.5, A will be plus 0.5. Okay. Boleh? So you just imagine ini satu-satu. Contohnya, you just imagine dulu kamu buat display memang satu-satu. So bila satu-satu, let's say the number of ice cream 111, betul? The number of ice cream 1, 2, 3, 4, 5. Do you have number of ice cream 2.5? Tak ada. So when you have number of ice cream, it is discrete random variable. When I want to change it, it's continuous random variable. Object yang sama, masih lagi ice cream. What can we analyze on the quantity? What can you analyze for continuous random variable about ice cream? Volume. So bila volume, contohnya kalau volume, you tunggu dia cair lah. Alright? So bila you tunggu dia cair, dia akan jadi continuous random variable when you analyze on its volume. Boleh. So ini yang kamu akan dapat. Tolak 0.5. Sini tambah 0.5. So this is what can we see from here. Boleh. So you just imagine your discrete, bila dah cair, dia akan sampai mana. Sempadan dia boleh sampai mana. Okay, concept of CC, continuity of correction. So this is happen on our questions. So overall, from distribution we change. From the questions that given, we also need to change. Then after that, what do we do? After we change to continuous random variables ini, then we follow through. We will solve using normal distribution. Then we start with the N, the next flow Z, the next procedure D, drawing, then table, then answer. So we no longer using binomial distribution to answer that situation. So we use normal distribution to approximate untuk menghampiri lagi discrete binomial distribution ini. So in your syllabus, you just learn one approximation, which is how you change binomial to normal. But actually in real life, how you change binomial to Poisson, it is occur. How the Poisson change to normal is occur. So dia ada lagi banyak approximation. But your level, we focus one on it. How to change binomial to normal. Boleh?